Hi my dear students, welcome to our channel Learn Physics with Guna sir. If you are watching our channel first time, please subscribe. For more updates, click the bell icon. Thank you.
Construction of DC variable power supply. The required components: a step down transformer of 18 volts from 220, LM317 IC regulator, PCB, LED, 1N4007 diodes, rectifier diodes, some resistors, an electrolytic capacitor, the circuit diagram for DC variable power supply is as shown here. It contains a bridge rectifier, a filter capacitor and a regulator. 4007 diode has this kind of band. The band denotes its cathode, the negative. 4 such diodes are employed here in this circuit, and the capacitor of 35 volts rating, 2200 microfarad capacitance is used here. This is LM317. The 3 legs of the IC 1, 2 and 3 are shown here. An LED, a resistor of 330 ohm, a potentiometer of resistance 5 kilo ohm, and another resistor of 10 kilo ohm, a current limiting resistor, an LED used for pilot lamp. The long leg of the LED denotes its anode, the positive. Other one will be negative, cathode. Similar 4007 diodes, 3 diodes are employed here to reduce the voltage from 1.25 to 0 and another 2.2K. First join the 4007 diode on the PCB and carefully solder it. First cut the leads and then carefully solder. Now take the second one and do the same process. Solder it very close to the first one, and later we will join the 2 leads according to the circuit. These are the 2 diodes. Their cathodes are to be joined later. Now it comes to the other 2 diodes. After joining all the 4, it appears like this. Now the 4 are shown on the PCB. Now the turn comes to the capacitor. Take the capacitor, place it on the PCB and carefully solder it. Cut the leads and solder. After soldering, it appears like this. Now it comes to the 10K resistor. Again you solder it. Then LED. The positive of the LED is connected to other end of the 10K resistor. After that it appears like this. Now take the LM317 and carefully solder it on the PCB with the help of a heat sink. These ICs are sensitive to temperature, so to avoid damage to the IC, use a heat sink like a nose player, hold it and solder it carefully. Don't short the leads. Now take the 330 ohm resistor and join it to the second lead, that is the central lead of the IC regulator. Again solder it. Now it comes to 4007 rectifier diode. Here 3 diodes are employed to reduce the output voltage from 1.25 to 0 volts. Each diode in forward bias offers 0.7 volt drop Only 2 diodes are sufficient in principle, but we add the third one to ensure the minimum 0 at the initial stage. So we are joining the 3 one after the other. It forms a serial combination. Now the 3 are joined. Now it comes to the 2.2k resistor, and the other end of the 2.2k must be grounded. That is, it must be joined to the negative of, not sorry, it must be joined to the positive of the diodes. Now potentiometer. Take the potentiometer and short the 2 leads and solder. Take the third lead, again solder it to the third one. After soldering, we will have continuous variation of resistance from 0 to 5k. This is the soldered one. Now join the 2 ends on the PCB. One lead after 330 ohm resistor and another lead to the ground. This is now 330 ohm resistor. Now the other one, it must be joined to both 2.2k, the diode, and the LED's negative. All these terminals are connected and this form the ground. Now do the soldering at 2.2k. After soldering, now connections are like this. Now shorting of components. The 2 diodes are not interconnected, so we must make the connections with the help of some connecting wire. Similarly, it is showing the positives of the diode that are to be joined to form the ground. Now after joining with the help of a wire, it appears like this. So those 2 are now shorted. Now from the negatives of the diode, it must be connected to the positive of the capacitor. So those connections are also shown here. After connections, it appears like this. Now the other end of the capacitor, that is the positive of capacitor, must be joined to the LM317 also later. It is showing the positives of the diode which are joined to the negative of the capacitor. So these connections are shown from the back side. Now let us join the positive of the capacitor with the 10k resistor as well as the third lead of LM317. So now we are showing the third lead of LM317, that is going to be joined with 10k resistor as well as positive of the capacitor. Now the negative of the capacitor and the negative of the LED are to be joined with the other end of 5 kilo ohm potentiometer. Once again we are showing the connections between the diodes, positive of the capacitor, 10 kilo ohm resistor and LM317. All the connections are now made. They are very clearly seen on the PCB. A metal wire is shown there. Now it comes to the potentiometer. One end of the potentiometer is connected to 330 ohm, and now the channel we are showing here is the pilot lamp. This is a 10k current limiting resistor. Now the 2.2k is once again shown in series with the 3 diodes, and they are coming to the second lead of the regulator. So the diodes and the second lead of the regulator must be joined. Similarly, the first lead and the second lead of the regulator are joined through a 330 ohm resistance as shown in the figure. So the second lead is now shown, that is to be joined with and after that this is the connection to join with the step down transformer. Solderings are made, and these connections are made at the middle portion of the diodes. the connections are shown in the circuit diagram. Now the second lead is going to be joined. Now after soldering, we will have the 18 volts RMS power joined to the circuit. So it is fed to the bridge rectifier. Now it is turned to join the AC power, that is 220 volts, with the help of an external cord. So connections are now made, insulation is going to be done, and this is the cord plug. After insulation, our power supply is ready. Let us plug it. The pilot lamp now is going to glow. Yeah, it's now glowing. So the circuit is working. It is time to take the output. So take the output across the 2.2k resistor, one from ground, another one from the other end of the 2.2k. So two connections are to be made on the PCB. These connections will serve as the output leads, and after connections, let us check what is the voltage obtained. Turn the multimeter into DC mode, 200 volts range, and connect the leads, and then hold the potentiometer and carefully turn it. Take the potentiometer and slowly turn it. Now have a look at the multimeter. It is now showing 0, and on increase it is increasing 4, 5, 6, 7, 8. Now it's increasing and reaching to 20. So 20.5 is the maximum voltage obtained. The maximum voltage depends on the AC input voltage. Thank you.